We want to understand our place in the universe, why we came to be here, whether or not there's alien life on another planet somewhere in the galaxy. And my research asks the fundamental question about how likely is it that there is another planet somewhere in the galaxy which could host life.
We can't be alone, can we? When stars form, they form within a nebula, a cloud of gas and dust.
And these gas clouds are very, very cold and they're very, very heavy. The combination of those two things causes them to collapse and they fragment into lots of pieces. And those pieces of gas contract and eventually form stars.
And around these stars, there are disks of gas and dust which are left over, and these are what go on to form planets. And there are loads of stars forming at once. They form close together.
And you might have hundreds or thousands of stars in the same volume of space that the sun and its nearest neighbor in the galaxy today occupy.
Which is how these siblings, these binaries come about and these clusters come about.
And when you have stars that close together, they interact with each other, and these young stars have already started to form their planetary systems.
So in a star cluster, the stars are really a lot closer together. This makes the system denser, which means
you can change the makeup of planetary systems. You can eject planets from one system so they become free-floating or rogue planets in space. And also, you can swap planets between stars. So some of the planets that we observe in the galaxy today probably didn't form around the star that they orbit, and they were swapped.
There's possibility for interstellar objects to travel between systems. And if these interstellar objects are carrying life, there's a possibility that they could plant life into another system and potentially form a planet with life like our own. It's a theory that's been explored. It's called panspermia.
Panspermia is the transfer of life between systems in space. And there are several ideas that suggest that this is how life on Earth formed. Fairly recently, we've discovered what's called an interstellar object, Oumuamua, traveling through space. This was rapidly followed up by the discovery of another object called Borisov. The fact that we've seen objects traveling between planetary systems suggests that you can certainly transfer rocks between planetary systems. Whether or not these rocks have life on them is a totally different question, and this is something that we have people working on in my research group.
We're looking at the possibility for this idea of panspermia being a way that life could have been transported to our solar system, or a way that life could be transported between systems and give a new theory of the formation of life.
In order to have the conditions that we require for life to develop on our planet, we need the Earth's history to be relatively quiescent and quiet. And so what that means is that the type of interactions that we think are experienced by some planetary systems cannot have happened to Earth and our solar system as it was forming. And so the implications are that if a planetary system hasn't experienced a dynamic or destructive interaction with another star, the chances for life developing on that planet are much, much higher. And so we need to know the relative proportion of stars and planets that don't undergo these dynamic interactions compared to stars that do, because that gives us an idea of how many planets in the universe might be like ours and might have developed life. I'm very excited to know what the answer to that question is, because if we find that life is common on other planetary systems, then we need to understand how it's common, why planets form life so readily. On the other hand, if we can't find any of these biosignatures, we need to understand what it is about our planetary system that was different or unique to all of the other planetary systems in the universe. It's going to raise more questions than it answers, and that's the most exciting thing about scientific research, is there's never an end point. There's always something else you can discover, and there's always more questions that you can ask.